Welcome everyone, I'm Adam. In this problem, we're going to be finding the standard form of the equation of hyperbola with the given characteristics. We're told that the vertices are at points 2, 3, and 2, -3, and that the hyperbola goes through the point 0, 5. So to start with, we're going to go ahead and just plot the points of our vertices. We're not going to sketch the graph of the hyperbola, but just to help us visualize and see what the standard form of the equation is going to be. We see we have vertices at x value 2 and y value positive 3, and at x value 2, y value -3. So what does that tell us? Well, we see a vertices going in a vertical line, so that says the transverse axis is going to be vertical. So that at least gives us the idea of what the standard form of the equation is going to start to look like. So we're going to have quantity, say, y minus k squared over a squared minus quantity x minus h squared over b squared, and that's equal to 1. So what we can do is we can find our k, our h, our a, and our b, plug them in, and we have the standard form of our equation. Now before we go too much further, we can find the k and the h, which are the coordinates of the center of the hyperbola. So if we look at what we have graphed, right, we have our vertices at these 2 points, and we know that the center is the midpoint of the vertical line, or the transverse axis, between the vertices. So if we go equidistant, we can see we have going from 3 to -3, which is a total distance of 6. Half of that is a positive 3. Right? So that tells us that our center point is going to be right here. So our center, right, HK, is going to be at the point x equals 2, y equals 0. Right? And that also tells us something else. What is A? A is going to be the distance from the center to the vertices. So our A is namely also going to be equal to 3. Okay, so coming back over here, we have K, H, and we have A. All we need to do is find B. Now, normally, when we're working with ellipses, we had a relationship between C, A, and B that we would use very commonly. And here with hyperbolas, we have this relationship that C squared is equal to A squared plus B squared. Now, like we said, we know what A is, right? So this is 3, or it would be 3 squared. We don't know what B is, and we don't know what C is, though, either. And the problem is, C being the distance from the center to the foci, we have no idea what the foci are here yet, so we're not going to be able to find what C is. So actually this equation, which we used commonly before here, is not really going to help us. So what can we do to find B? Well, let's go to the next piece of information that we were given. We have that the hyperbola passes through the point 0, 5. So that means at x equals 0, y equals 5. If we plug that into the standard form of our equation and simplify it, it should be equal to 1, with the only unknown that we would have would be B. So we can solve for B. So what do we just say? So in the standard form of our equation, plugging things together, we're taking as y, the y value from our point is 5, minus k, the y value from our center, which is 0, quantity squared over a squared, right, or 3 squared, and then minus x minus h, so the x value from our point, 0, minus h, or the x value from our center, 2, quantity squared over the unknown b squared, and that's equal to 1. So with this equation, we can solve for b. So let's go ahead and do that. So we have 5 minus 0 squared over 3 squared. That's going to give us, all right, say 25 over 9, minus -2 squared, we'll have positive 4, over b squared, and that's equal to 1. So now we're just going to do some algebra and solve for b. So we'll try to walk our way towards getting b squared isolated on one side. First, let's go ahead and subtract this 25 over 9 from both sides. Right? So 1 minus 25 over 9, 1 is 9 over 9, so minus 25 over 9, is going to be equal to a negative, say, 16 over 9. So what do we have? And lastly, before we go on, the two negatives can cancel. So to clean it up, what do we have? We have 4 over b squared is equal to positive 16 over 9. Okay, so I want to get b squared in the upstairs position. So let's start by multiplying both sides by b squared, where the b squareds will cancel over here. So that's going to give us 4 is equal to 16 over 9 times b squared. And we want to get rid of the 16 over 9 here. So on this side, we'll multiply by 9 over 16 and do the same thing over here. Multiply by 9 over 16. So the 9/16 cancels with our 16/9 on this side. 9 over 16 times 4. The 4 will cancel with the 16 in the denominator. So that's going to leave us with 9/4 is equal to, say, b squared. And taking the square root of both sides, that's going to imply that b will be equal to 3/2. Okay, so we have our a, our b, and then our k and our h. So now we can find the standard form of the equation and put it all together. So putting it all together, so we're going to have y minus k, or y minus 0 quantity squared, over 3 squared, minus x minus h, or x minus 2 quantity squared, over b squared, or 3/2 squared, and that's equal to 1. So this is perfectly acceptable for a standard form, but we can also simplify the denominators if we want to, and also drop the 0 in the numerator in this term. So this could also be written as, just cleaned up a little bit, y squared over 9 minus x minus 2 squared over squaring the 3/2, 9/4, and that's equal to 1. So there's two forms of the standard form of our hyperbola with our given characteristics. So there we go. Thank you very much.